and welcome back to another episode of Research Done Right. In today's lesson, Lesson 8, we're going to be talking about experimental design. In today's lecture, I'm going to introduce you to some of the most basic experimental designs, but before we do that, we're going to revisit the topics of confounds and validity, two things which are going to be critical to a successful experiment. Once we discuss different types of experimental designs, we'll also learn about independent groups or between subjects design, as well as dependent or within subjects designs. We'll also talk about the pros and cons for each type of design so that you will be better equipped to start on your own research projects. So let's begin by talking about confounds and validity. A confounding variable is something that is not held constant, meaning that it can change along with the independent variable, but contrary to the independent variable, the confound is not controlled or manipulated. So if you think back to our previous discussions about validity and confounds, another word for confound is the third variable. So typically when we conduct experiments, we are trying to find causal inferences between the independent variable and the dependent variable. Anytime there is an indirect effect from a third variable on the dependent variable, that becomes a confound. It convolutes our internal validity, therefore making our experiment much weaker. And it is weaker because we are unable to clearly identify if the differences in the dependent variable are truly caused by the independent variable or some alternative explanation. So confounds can lead us to have alternative explanations. Let me give you an example. Let's imagine that as a researcher, you are interested in measuring whether exercise affects a person's mood. So for example, you would have one group, the experimental group, exercise for 30 minutes, and then you would assess their mood by giving them some mood assessment scale. You could have a second group, a control group, who would view a video of people exercising, but they would not exercise themselves. And then you would give them a mood assessment as well. And basically what you would do as the researcher is compare the moods of the people who did exercise versus those who simply watched people exercise. Okay, so that sounds like a totally valid study. But imagine if the group that was exercising in a room with big spacious windows where they could see the sun shining through, and the group that was viewing the people exercise, they were in a room without any windows. Perhaps it was dimly lit, and so they were in a different type of room. So is it possible that the people's mood could have been influenced by the environment in which they were given the mood assessment, regardless of whether they exercised themselves or whether they watched a video of people exercising? Because the room, the lighting, the presence and absence of windows, all of those things were not held constant, those all can become confounding variables. All of those can indirectly have an effect on the dependent variable. So as you can see, those are alternative explanations that can be causing the difference that we are seeing in the dependent variable. So what type of validity do confounds affect? Well, that would be our internal validity. Internal validity tells us how truly the conclusions are based on causal relationships of the independent variable on the dependent variable, and not due to any other factors. So if those windows, if the lighting, if the atmosphere of the actual room had a significant effect on the dependent variable, on the people's mood, then it would be called a confounding variable or a third variable, because the causal relationships that we are seeing was not due only to the exercise, right? It was not only based on the manipulation of the independent variable, but it was based on this other third thing that we did not manipulate and we did not control for. So the true experimental design has the highest degree of internal validity. So how do we reach a high degree of internal validity? Well, first of all, we avoid confounds and we practice experimental control. But the second thing is to use random assignment. So remember, random selection of participants is different than random assignment of participants. Random selection means that anybody in a particular population has a fair chance, an equal chance to participate in your study. Once they are selected for your study, they need to be assigned to a condition. Going back to our exercise example, the first condition was the group that did exercise for 30 minutes, and the second condition was the group that watched an exercising video for 30 minutes. So random assignment means there is no specific criteria or preconceived information that you are collecting from participants to determine which group they will be assigned to. So not only are you randomly selecting the participants, you must also randomly assign them to conditions in order to have the highest degree of internal validity. All right, so now let's talk about some basic examples of experiments. The simplest experiment has at minimum 2 variables. The first would be the independent variable or the cause, and the second would be the dependent variable or the effect. The independent variable has to have a minimum of 2 levels. Why? Because any experimental design that you have has to have some type of a comparison. So you can't conduct an experiment with only one group. You always have to have another group to compare that group. So we typically have a minimum of 2, the experimental group and the control group. So ultimately, by making this comparison between the 2 groups, you as the researcher are able to see if there is a difference between these 2 groups based on your manipulation of the independent variable. So in our exercise example, our independent variable was exercise. In the experimental group, we had them exercise for 30 minutes. In the control group, they did not exercise and they simply watched a video of other people exercising. If I wanted to, I could add a 3rd level to this independent variable in which I have people exercising for 1 hour instead of 30 minutes. So in that case, my independent variable would still be exercise, but it would have 3 levels: exercising for 30 minutes, exercising for 1 hour, and not exercising at all. And so ultimately what I would be interested in is to see the mood rating across all the 3 different conditions. So most experiments utilize the post-test only design. If you think about the word post, post means after. So when we talk about the post-test only design, we are talking about collecting information, collecting our data after a manipulation of the independent variable. So the first thing we would want to do is obtain 2 equivalent groups of participants. Once we have our number of participants, we will randomly assign them to the different conditions. And ultimately, you want to make sure that you have an equal number of participants in each condition. Once you do that, you are going to introduce the independent variable. You're going to give them a particular dosage of the variable. You're going to have them participate in a certain activity for a certain period of time. Whatever it is that your manipulation may be, you expose the participants to that level of the independent variable. Then what you would do is measure the effect that the independent variable had on the dependent variable. And remember, the dependent variable is typically the thing that we are measuring. So again, the post-test only design is based on a random selection of participants and as well as random assignment. So not only do you randomly collect the participants, you also randomly assign them to conditions. The second type of experiment we'll talk about is the pretest-posttest design. So recall the previous one we just talked about was called the post-test only design, in which you administer a level of the independent variable and then you measure your dependent variable. With the pretest-posttest design, you actually are going to give a baseline measure prior to introducing your independent variable. So basically the pretest is given to all of the groups before you introduce the manipulation, before any level of the independent variable is experienced. The whole point to giving groups a pretest is to confirm that the groups are equivalent at the beginning of the study. So for example, if we return back to our exercise example, if you randomly selected and randomly assign participants to exercise versus no exercise groups. And again, the dependent variable is to measure their mood after these 30 minutes are up. Is it possible that the participants that attend your study could already be in a good mood? Perhaps they already had some sort of good news that came to them prior to them attending your study. Or perhaps they're just really excited to be there. On the contrary, you could also have participants who may have experienced something upsetting or disappointing earlier that day. Ultimately, it is entirely possible that the mood of the people is already going to be set a certain way prior to even interacting at all with your specific experiment. So how could you test this? How could you control for this, right? Imagine that by coincidence, you had really happy people in the exercise condition and not so happy people in the condition that did not exercise. In the mood assessment at the end, you will definitely have seen a difference in the mood ratings between exercise versus non-exercise. But to be entirely sure that the mood differences are caused by the exercise variable, it would be great to give them a pretest measure. So the pretest, again, it's not like a test of skills or abilities, but basically it's a measure that you're giving them before you introduce the independent variable. So imagine that you gave all of your participants in both groups a mood assessment scale, the same one that you're going to give them after the independent variable exposure, but you're going to give it to them first at the beginning of the study, then you're going to introduce the independent variable, and then you're going to measure their mood again. So basically, if your participants are if all the participants score at a similar mood and there are no significant differences between mood ratings across the two independent variable conditions, then that would confirm that your participants are pretty similar at the beginning of your study. That would also conclude that any differences that you see in their mood post independent variable, right after the exercise exposure, that would indicate that all of the differences are based truly on the independent variable. So typically a pretest is not necessary if participants are randomly assigned, because the randomization makes up for the fact that we can control for individual differences. But pretest and post-test design is also helpful if you think that attrition or mortality is likely. So mortality basically means when people withdraw from a study, right? If your study is spanning a specific amount of time, if it's not just a one-time thing, perhaps it's lasting weeks or months, it's entirely possible and common that participants tend to drop out of the study, right? They move away, they get sick, they can't make the commitment anymore. And so you will obviously start to see differences in your dependent variable towards the end of the study. So having a pretest measure before you start anything is also really helpful, because at least you could see a baseline measure of where the participants stood at the beginning of the study. The larger your sample size, the less likely it will be that the groups will differ prior to the manipulation of the independent variable. So what does this mean? Remember when we talked about sampling and collecting samples from populations? The larger our sample, the more representative it will be of the population from which it came. Therefore, it's better to take larger samples so you can represent more individual differences. And therefore, if you have this random selection of participants and your sample is large, the individual differences among the groups before the administration of the independent variable should be fairly equal, should be the same. And that's something that you want as a researcher. You don't want your participants to differ from each other before you implement the independent variable. That way, after you implement the independent variable, if you do see changes in their behavior or in their mood in this particular example, then you can comfortably say that the differences were caused by the independent variable alone and not because of individual differences. Okay, so we know that we want large sample sizes, but what is that size, right? What is the desirable number of participants that we should have in our experimental design? Well, depending on how many conditions you have, the rule of thumb, the heuristic number, is typically 20 to 30 participants per condition. So if I have two conditions of exercise, either exercise for 30 minutes or don't exercise at all, those are two levels, two conditions. I would want to have 20 to 30 participants in one and 20 to 30 participants in the other. So anywhere between 40 to 60 participants would be a powerful sample size for this type of experiment. Now remember, I suggested that we could add an even third level, right, where participants could exercise for 1 hour. So we had 1 hour exercise, 30 minutes, and no exercise at all. That would give us three conditions. So 3 times 20 or 3 times 30 would expand that to 60 or 90 participants. So again, a good way to calculate how many participants you need is think of approximately 30 participants per condition. So let's take a closer look at the pretest-post-test design. On the left-hand side, you collect your sample of research participants. Again, ideally, the participants are randomly selected. Once you have a group of randomly selected participants, you begin to randomly assign them to either the experimental group or the control group. And when we randomly assign, you can use things like a number generator. You can use like a binary code, like your group 1, your group 2, group 1, group 2, group 1, group 2. You can have people pull numbers out of a hat. But ultimately, the process is totally random. You are not basing their participation in either of the groups, experimental or control, based on any like demographic information or differences, individual characteristics that you know about the participants, right? It's totally random. Okay, so you've randomly assigned an equal number of participants to the experimental and the control group. Then you have O subscript 1. O stands for observation, and the 1 stands for the first observation. So O1 represents our pretest. Then we have the implementation of the independent variable, also known as the treatment, and it is symbolized by the letter X and a subscript of T for the treatment or the experimental group, and a subscript of C for the control group. So up to this point, both groups had the same number of interactions with the independent variable and have already given a pretest observation. Now the third measure in the pretest-post-test design is O sub 2. O sub 2 represents observation 2, which is going to be the post-test measure. So if we talk about this in context of our exercise study, pretest 01 would be the mood assessment prior to experiencing any type of exercise. The treatment for the experimental group would be exercising 30 minutes, and the treatment and the independent variable for the control group would be watching a video of people exercise for 30 minutes. And then O2, the post-test, would be the same mood assessment, the same mood scale. So if I actually wanted to prove and confirm my hypothesis that exercise does have a significant effect on mood, I would expect that the O1, right, the first observations on the pretest between groups to not be significantly different because nothing was different for them at that point. However, in O2, right, for observation 2 in the post-test, that's where I would expect to see significant differences in mood ratings. So it sounds like a pretest-post-test design is a great idea. And oftentimes it is, but it does have some disadvantages. First of all, conducting a pretest is time-consuming. Conducting any experiment is time-consuming, so adding an additional observation in there just increases the amount of time you would have to spend. It can also sensitize your participants to what you're studying, thus enabling them to figure out what you're studying and why, and this could then further lead to reactivity. We remember from our previous lectures that reactivity refers to participants behaving in a certain way when they know they're being watched or measured, which is unnatural from the way that they would naturally behave. So imagine that you give participants a mood assessment for the pretest, then they exercise or don't exercise, and then you measure their mood again. So participants might catch on and say, this researcher is interested in my mood. Well, you know what? I'm going to just say that I'm feeling happy, even though perhaps I'm not feeling happy. It also makes it difficult to generalize to others who did not take a pretest. So remember when we talked about different types of validity, we said that external validity is our ability to generalize our findings to a larger population. Generalizing these findings to participants who did not take a pretest measure, right? To participants who did not indicate their mood on a scale prior to exercising, it would be hard to generalize to that type of population. And lastly, pretests are rarely given in the real world, right? So in a laboratory setting, in order to maintain experimental control, the more information we have about participants at various stages of our experiment, the better. But if you think about it in the real world, people don't often analyze their mood before they exercise and then analyze it again once they're finished, right? It's typically it's an assessment of how we feel after we've completed something, after we've engaged in an activity. It's rare for us to actually reflect on how we're feeling before we do the given activity and then once again after. So one way that we can avoid these disadvantages is by using what is called a Solomon four-group design. The Solomon four-group design uses a combination of the post-test only method and the pretest post-test method. So let's take a look. On the left-hand side, you see participants. The R represents random selection as well as random assignment. So from participants, you have two arrows. One arrow goes up, and we see that we have a random assignment to an experimental group and to a control group, followed by a post-test observation, right? We measure the dependent variable based on which level of the independent variable the participants were exposed to. However, the arrow that takes you to the bottom from the box, the participants box, takes us to a pretest measure for both groups. After the pretest measure, we randomly assign people to the experimental group or the control group. So that's the implementation of the treatment of the independent variable. And then we measure them on the post-test measure, right, measuring the dependent variable. So basically, the Solomon four-group design, the four groups here are post-test only design, which means experimental and control, and only a post-test observation, right? There was no pretest here at all. So again, the group experiences different levels of the independent variable, and then they're given their mood assessment. However, it's comparing those two groups to the other two groups that actually did receive a pretest, then the independent variable, and then the post-test. So ultimately, we can see whether the groups did differ at the pretest level and whether they differed at the post-test level, but it also takes into consideration the post-test only design in which no pretest existed, so that we could still see the representation of participants who were not sensitized to what the researcher was studying, who did not spend as much time giving a pretest measure to all of the participants, right? And also allows us to generalize to the population in which the participants did not experience a pretest. So basically, the Solomon four-group design uses a combination of the post-test only design, which we see at the top, and the pretest post-test design, which we see at the bottom. So let's talk a little bit about how we assign participants to different conditions. We have two basic ways of assigning participants to experimental conditions. The first one is called independent groups design, or between subjects. And this is when our comparisons are made between different groups of participants. Again, we use random assignment, right? Our decision should always be to assign participants to a condition completely arbitrarily, beyond our particular control. We know nothing specific about the participants. We don't know their current exercise schedule. We don't know what they're currently eating. We don't know if they're happier in the morning or in the nighttime, right? All of these things are arbitrary. We're not looking for them. We're not trying to control for them. And so by using random assignment, we're going to be able to represent a variety of individual differences across the two different conditions, so that those specific characteristics and individual differences of the participants are not going to be the things that influence their mood after they've exercised or did not exercise. The second type of comparison is called repeated measures design, or within subjects. And within subjects design, comparisons are made between the same group of participants over time. So for example, if you wanted to test the effects of exercise over a month's period of time, you would probably want to test it on the same people. So there are different research questions that lend themselves to different types of design and different types of participant assignment. The other time that you would use repeated measures or within subjects design is if your participants are very, very similar to each other. So people like identical twins, siblings, families that are very close. And the reason behind this is that the variance, right, the chances of them being super different are going to be smaller because they're already so close, right? They're used to spending a lot of time together. They have similar attitudes and beliefs, etc. And this will cause them to perform similarly on any type of measure of a dependent variable. So anytime you have measuring the same people more than once, or if you're measuring people that are very, very closely related, you would be using repeated measures design. But anytime that you're comparing different people to each other across different conditions, that would be independent groups or between subjects design. And so repeated measures design also has its own advantages and disadvantages. So let's talk about the advantages. Well, the good news is if you are interested in tracking some type of manipulation or independent variable over time, this is a great way to do so because you can follow certain participants over time to see how their behavior or mood or whatever measure have you changes from one point to another. So you're basically testing the same participants more than once. Because of this, you limit the number of participants that you actually have to have. Remember, we said 20 to 30 participants per condition. If your condition is time, right, 1 week, 2 weeks, 3 weeks, 4 weeks, the participants in a repeated measures design act as their own control or comparison group, because essentially you are comparing those same people to themselves just at different points in time. So it saves you time, money, and effort on recruiting more people because you get to use the same people over time, which means that less participants are needed and you're still able to collect a large amount of data points. Additionally, if you have repeated measures design, the effect of your independent variable is much stronger. It's much more prominent. Because the people aren't changing, you are not introducing more variance due to individual differences, right? So you will have less error variance due to the individual differences because you have less individuals in your study in the first place. So basically, this means that people are less likely to differ from themselves over time than they are to someone else. So whenever we talk about the variance of different people within a particular condition or a particular level, we call that error variance, right? Because we as researchers cannot control for the individual differences that exist among the people. However, if you are comparing the same people to themselves over time, they are less likely to differ drastically from themselves. Now let's look at some disadvantages of repeated measures design. The first disadvantage is called the order effect. Basically, this means that participants may show a greater effect because of the order of the presented stimuli. So basically things like primacy and recency. We know that primacy refers to the fact that people tend to react or remember information more prominently if it happens at the beginning, and recency if it happens at the end. So basically, if they're being measured on a particular assessment, whether it's mood or behavior or score on an exam, etc., people are going to remember the questions that appeared at the beginning and the end of the assessment. And because you're giving them the assessment multiple times, they will already have memorized what you're going to be asking them in which order. And we also have directly related the practice effect. So participants may show improvement not necessarily due to the independent variable, but due to the knowledge of the stimuli after the first trial. So for things like exercise and mood, this wouldn't really apply, but imagine that you were interested in testing the effects of a GRE graduate record exam tutorial program, right? And so you give students the GRE exam before the special tutorial and training. So you have a pretest measure, and then you give them the tutorial, you give them the training, that's your independent variable, and then you measure their score on the same test again. It's entirely possible that they may have looked up the correct answer between observation 1 and observation 2. Perhaps they, in retrospect, realize that they marked a particular answer incorrectly and they fixed their mistake all on their own without the help of the training program. So we can't really see, we can't tell, we can't confirm that the improvements that we see between the 2 observations or 3 observations or however many you have are actually due to the independent variable or to the fact that the participants just had so much practice with these questions already that they're bound to get them right. We also have the fatigue effect, where participants can become tired, bored, or unmotivated after doing the same thing multiple times, right? So you don't want your experiment to go on and on and on forever, or if you do have it in a longitudinal format, you probably don't want to give the assessment to participants too frequently, as that can tire them out and unmotivate them. And lastly, we have the carryover effect. Carryover effect says that participants may still be under the influence of the first trial when beginning the second one. So essentially, if you are going to use repeated measures design and you're going to implement your independent variable, you want to make sure that there is enough of a reset period between the different observation times so that the effects from the previous observation don't carry over into the second one. Carryover effect is something that often happens with medication or dosages of treatment. So let's imagine your participants show up because there is new research being conducted on special medication that reduces levels of stress. So participants receive 1 dose of your anti-stress medication and they record their level of stress, and then not enough time passes before you give them the second test measure of the dependent variable of their stress level. And basically they still don't feel stressed because they're still under the influence of the first dosage of the medication. So depending on what your independent variable is, you want to make sure that you space out the manipulations, the exposures to your independent variable, as well as you space out how often you assess and measure the dependent variable, right? You don't want to overload the participants, you don't want to make them tired, but you also want to make sure that you understand how much time it will take for the effects of the first level of the independent variable to wear off, so the participants can then give you the following observations from a neutral state of mind. So what we often use to avoid these effects or these disadvantages of repeated measures design is to use what is called counterbalancing. Counterbalancing allows you to mix up the order of the levels of your independent variable or your stimuli so that participants don't feel like they're going to get used to a particular order, and no 2 participants necessarily will experience the same order of your stimuli. So for example, if I have 6 different participants or 6 different groups of participants, I'm going to switch around the order in which I expose them to the independent variable. So let's go back to our exercising example. And this time, let's use the 3-level version. So level 1, participants exercise for 30 minutes. Level 2, participants exercise for 1 hour. And level 3, participants don't exercise at all. So imagine that I used a repeated measures design for this experiment, which means that I'm going to use the same people, and the same people are going to experience all 3 conditions. So let's say A in our chart here will represent not exercising at all. B will represent exercising for 30 minutes, and C will represent exercising for 1 hour. And let's say I conduct this experiment on a Monday, Wednesday, and Friday. So 3 days out of the week. So for group 1, the participants in group 1, they will experience on Monday no exercise at all. They're going to just watch a video of other people exercising, and then I'm going to rate their mood. On Wednesday, the same people are going to come back and I'm going to have them exercise for 30 minutes and then I'm going to measure their mood. And then on Friday, those same people will come back and they're going to exercise for 1 hour and then I'm going to measure their mood. For everybody in group 2, they will also start with no exercise at all on Monday, but on Wednesday, they're going to exercise for 1 hour. And on Friday, they're going to exercise for 30 minutes. So we've switched the position of the 30 minutes and the 1 hour exercises between groups 1 and 2. So therefore, in case there are any carryover effects, in case there are any practice or order effects, they will be eliminated because now I have a different representation of order of my independent variable. If we look at groups 3 and 4, those are now going to start with 30-minute exercises. And group 3 is going to come on Monday, exercise for 30 minutes, not exercise at all on Wednesday, and then exercise for 1 hour on Friday. Group 4, conversely, will also exercise for 30 minutes on Monday, but on Wednesday will exercise for 1 hour, and on Friday will not exercise at all. And so for groups 5 and 6, as you can see, those groups will start by exercising for 1 hour on Monday, and on Wednesday they will either not exercise at all or exercise 30 minutes, and then on Friday, correspondingly, they will exercise 30 minutes or not exercise at all. So this is an example of counterbalancing. By putting your levels of your independent variable in different order, all of this will cancel out all of those previous disadvantages that we talked about when it comes to repeated measures design, when it comes to using different participants over time. Now, if you are going to do between subjects design, right, independent samples, group 1, 2, 3, 4, 5, and 6 would all be different people. You could still counterbalance across different groups, and that would still also be good to show you how the different order in which people exercise or don't exercise could also have an effect on your dependent variable. But counterbalancing is very important for repeated measures, and it could be used for independent or between subjects design as well. All right, so as a recap, in this lecture, we revisited the danger of confounds and how it can harm our internal validity. We talked about basic experimental designs such as the post-test design, the pretest-posttest design, and the Solomon four-group design, which is a hybrid of the previous two. We talked about the various advantages and disadvantages of using a pretest, and we also talked about how we should assign participants to groups, whether we should use independent groups or between subjects design, or if we should use repeated measures or within subjects design. Again, it always depends on the research question that you have. Repeated measures design also has its own advantages and disadvantages, and a way that we mitigate the bad things and the disadvantages that could happen as a result of repeated measures is typically avoided by using counterbalancing. So I hope you found this helpful, and I will see you next time on Research Done Right.